Okay, so quadratics, we learned how to factor, and hopefully then we'll use factoring as one of the methods to solving quadratics. In reality, quadratics can be solved three ways. We'll get to this a little bit later, but you can solve quadratics. One of those methods is by factoring. The other is by taking the square root of both sides, and I shouldn't say other, and the third is by using what's called the quadratic equation. We'll get to all of those here in time, but we're going to start off by solving quadratics by factoring. All right, so you got a quadratic. What is it? It's a second degree equation. So a quadratic equation is a second degree equation. All right, what's second degree equation? Well, we've talked about this before. Remember when we were talking about the degree of a polynomial? Am I frozen? So we were talking earlier about the degree of a polynomial. And the degree of a polynomial is the degree of the highest degree term. So if you look here at the standard form, there's the highest degree form. What's its degree? Second degree, and we have a quadratic. That's a simplified way of looking at it, but that's what basically you'll need to keep in mind as we solve quadratics. In other words, you got the variable squared. All right, and so quadratic equation, secondary equation, and therefore has up to, and this is the key concept you got to keep in mind, two real and or complex number solutions. Two real and or complex number solutions. So let me give you a normal looking quadratic equation. So how about something like 5x squared minus 2x minus 7 equals 0. It's a normal looking quadratic equation. 5x squared minus 2x minus 7 equals 0. All right, so this is a normal quadratic. Here's the thought process. So you're taking the ACT, you're taking the SAT, you're in your college algebra class, and all of a sudden a problem like that pops up. This should be your thought process. Oh, that's quadratic. How do I want to solve that? Do I want to factor it? Do I want to take the square root of both sides? Do I want to use the quadratic equation? That's your thought process. And that's where we need to get to by the end of the chapter. But the first thing is to recognize, oh, that's quadratic, because that's going to be solved in the manner that you solve quadratics. Don't need to draw this, but the picture up here at the top is trying to illustrate a parabola. You don't need to write that. We'll talk about it again later on when we actually graph quadratics. But it's a parabola, and it is the shape of quadratics. All right, Josh, you're gimpy, but I think you can catch, right? All right, so I'm going to throw the ball to him. Look at the shape of the ball. Here, and I'll get on the side because it'll look normal, more normal if I do this. All right, here we go, Josh. Okay, did that shape mirror the shape of the arrows? Now, again, the arrows are flatter. Mine was more pronounced. Josh lost that. Okay, if you look at this shape, it's a parabola. Now, I'm not trying to make it a parabola. All I have to do is throw it, and it's a parabola. That's the way it is. And this is a quadratic equation represents this shape. That's a quadratic. Okay, it's called a parabola. That's the shape. If you fire a mortar round, it's going to be in the shape of a parabola. If you're the outfielder for the New York Yankees and you're going to try to throw somebody out at the plate, guess what? It's going to be a parabola. Right? I mean, that's just the way it is. Such is the situation. Throw a football, it's a parabola. Peyton Manning's not throwing very good parabolas right now. Right? He's on the bench and he's out. In our fantasy league here that we play, I have Tom Brady. He's throwing good parabolas. He's getting me lots of points. But anything that's thrown besides being straight is a parabola. Those you guys on the basketball team, I'm trying to get you to not throw parabolas because parabolas get picked off. Okay? You want your passes to be straight. When you throw a parabola, it takes longer to get there and gives people time to intercept the pass. All right, but that's the shape. We'll deal with that a whole lot more later. Right now, what you have to recognize is if something's square, then it's quadratic. Thomas, that's not your phone, is it? Okay, good. Well, whatever it is, put it away because your attention is not where it needs to be. Okay, so we're looking at quadratics. So here's what I just mentioned a moment ago. Quadratics can be solved three ways. This should be in your brain. This is something you should memorize. It's just something you should have in your brain, something that should be memorized, and something where this is your thought process. All right, the first, factor. Now, when you think through it, you're probably just going to think factor. But the full idea is factor and set the factors equal to 0. But again, when I'm cycling through my mind the choices of how I'm going to solve a quadratic, I think factor is one thought. Second is take the square root of both sides. Take the square root of both sides. And again, when I'm thinking, I'm going to just think, all right, take the square root. And then third is the quadratic equation. The quadratic equation. It's a formula. The quadratic equation, which is a formula. So again, this is something you should memorize. When you come across a quadratic, you see that the variable is squared, you should be thinking, all right, do I want to take the square root of both sides? Do I want to factor and set it equals 0? Or do I want to take the square root of both sides? Do I want to use the quadratic equation? So memorize that. I'm sure you'll see that on quizzes and tests coming up. Go away. All right. Number 2. All right, so again, today is dealing with what? The aspect of solving by factoring, that first one. And the key to it all is the zero product property. The zero product property. Let me move this up for you guys. So the zero product property basically involves some simplistic aspects. If you have this scenario, two things multiplied together and they equal 0. That's all that represents. P is some quantity or number. Q is some quantity or number. You're going to multiply them together, they get 0. You know what? There's three possibilities. The first one is either P equals 0 or Q equals 0 or both equal 0. Right? Those are the three possibilities. There's no other way to get to 0 if two things are multiplied together. There's no other way. You cannot get to 0 with things multiplied unless at least one of them is 0. That's basically the zero product property. If you got a bunch of things multiplied together, at least one of them has to be 0. There's no other way to get to 0. None. No other way. No other way. If you're multiplying a bunch of things and the result, the product is 0, then one of them at least has to be 0. You'll never get there any other way. All right, so A, pretty simplistic. If 4x equals 0, guess what? X must equal, oh, you guys are rocket scientists, 0. X has to equal 0. It has to. There's no other possibility. There's no other way. Now, in the second example, what if we have negative 7xy squared equals 0? First off, can the negative 7 equal 0? Oh, again, rocket scientists, you guys are awesome. No, because it's a negative 7. Can the x equal 0? Yeah, so in this case, then either x equals 0 or y equals 0, again, or both equals 0. All right, those are the possibilities. There's no other way you'll get to 0. Has to be that. There is no other way. All right, so there should be a raised dot there between P and Q. And that's the scenario. All right, so now let's step it up. I'm trying to lead you guys somewhere, and I'm trying to lead you in a progression somewhere. So a moment ago, we did something simplistic. How about this scenario? Don't say anything out loud on this one. So here's what we have. 2 times quantity n minus 7 equals 0. Therefore, we conclude that n must equal, I didn't hear 0. I usually do, but it's not 0, is it? No. N must equal, what did I hear? 7, right? N's got to be 7. Because here's the reality. This quantity has to be a 0. That's the only way you're going to get to 0. It's got to be 2 times 0 to equal 0. And how does this quantity end up being 7? Or 7, how can you make it a 0 as if the n is 7? Mathematically, don't miss this. Students often do, and then they get goofed up later on. If you wanted to figure it out mathematically, here's all you've got to do. Although, you could do it in your head, right? Pretty simplistic, do it in your head. Let's suppose, how to do it mathematically. All you do is make a little equation, set that quantity equal to 0, solve the little equation. Add a positive 7 to both sides, and when the n is a 7, the quantity is a 0. Right? You just set the quantity equal to 0. Again, I'm hoping you're going to ask questions as we go along if you're not sure what in the world's happening, because you need to. All right, second scenario. What if we have the situation in D, where you've got the quantity y minus 4 times quantity y plus 1 equals 0? What now can you conclude? Don't say anything out loud on this one. What are your conclusions here? What must be the value of y? Somebody raise your hand and give me the value of y. Abigail? Abigail says then y must equal 4. Anybody agree with Abigail? 4. You should be agreeing 4 is correct. Is that it? Is there something else? Hunter? Or y equals negative 1. Now, catch this. I am not going to say, or the y is a 4 and the y is also a negative 1. Here's the point on this, and don't miss this. If I want to say y is 4, I mean this y is 4, and also that y is 4, and it'll get me 0. Because now the first parentheses is a 0, and the second is a 5, and guess what? 0 times 5 is 0. So when I say y is 4, I mean 4 goes in for both y's, and you'll get 0. When I say y is negative 1, I mean negative 1 goes in for both y's. In this scenario, the front parentheses is a negative 5, and the back parentheses is a 0, which again equals 0. So please don't think that we're saying, oh, one of the y's is a 4 and the other y is a negative 1. Oh, no, no, no. We're not saying that. We're saying if the y's are a 4, you get 0. And if the y's both are negative 1, you get 0. That's what we're saying. Okay? So we're saying both. Saying both. Okay. Next scenario. All right, how about E? Here's what we've got. 5 times quantity 2n minus 3 equals 0. I'm going to give you a second. I'm going to pause the video. You should pause it at home and figure out what in the world that is. Okay, so I didn't give you a ton of time here in class. How many of you have an answer? Let me see your hands. Okay, and the rest of you, you definitely missed this right here. When I said to you, oh, you can do this in your head, can't you? But if you want to figure out mathematically, what do? You take the parentheses, you set it equal to 0, and you solve the little equation. Can you now apply that to the question we just had? So those of you that didn't get it, do that now to this one and get the answer. Do that now to this one and get the answer. Again, there's some of you can still do it in your head. But what you're doing in your head is exactly that. All right, so in case you didn't catch it, take the parentheses, set it equal to 0, and solve the little equation. Add a positive 3 to both sides. Divide both sides by 2. When the n is a 3/2, the second parentheses is a 0, and therefore n is 3/2. How many got 3/2? Okay, now don't forget this. All right, I've been teaching this 30th year. Every year, students can't remember how in the world to get the value. You set the parentheses equal to 0. That's all you have to do. It's just a little equation. Very, very simple. Set the parentheses equal to 0 and solve. Okay. How about F? Give me the values of x for F. I'm going to pause again. All right, hopefully you had enough time to fool with that by now. All right, so let's see. Marissa, give me one value. X equals -3. How many agree with Marissa? X equals -3. All right, that should be all of you. I agree. That is one answer. Ben, give me another one. X equals 0. I agree. Ben got that from out here, right? X equals 0 is a second value. Does anybody have a third? Destiny, what do you got for the third? And 7/2 is the third. So let me show you mathematically how you would get all three of those answers if you want to see it mathematically. Again, any factor with a variable gets set equal to 0. There's the x equals 0. Nate?
On like testing quizzes, do you need to find all the possibilities?
Definitely you need to find all the possibilities, yes, because they're all the solutions. It goes back to the opening statement that therefore there are up to 2 real and or complex solutions for a quadratic. Our example right now is actually a third degree. And guess what? There are 3 solutions because it's a third degree. So yes, you definitely got to find them all. All right, so went backwards here. Let's go the right way. I'll stop with Windows. Okay, so that's how you get the first one. How do you get the second one? Set the little factor equal to 0, solve the little equation. There's the -3. How do you get the third? Set it equal to 0, solve the little equation, x equals 7/2, right? You're just setting each factor equal to 0. And again, this was a third degree. Oh, guess what? Not only do you solve quadratics by factoring, but that's actually how you solve polynomials of third degree and higher, by factoring. Okay, so there were 3 solutions to that because that was a third degree polynomial. All right, last example of this set. So now go ahead and tell me the values of x on that one. Okay, right now I think there are 30 of you in here. The norm would be probably 5 of you will get it right. That would be the norm. Okay, first time I introduced this. So I'm just curious, how many think they have an answer? Okay, about 6 of you maybe. Anybody get 0? X equals 0 is one possibility? No zeros? Not willing to admit it, huh? All right, just wondering. So what's different about the looks of all these, of C and D and E and F and G, Luke? They are all multiplied. So let's use a different word. What do I have to do to this? How about the title of the lesson? How many of you factored it? Did anybody factor it? A few of you? Well, I got news for you. If you didn't factor it, you're probably not going to get it correct. All right? You got to factor this thing. You got to get it to be factors. Because every other example, the zero product property is when things are multiplied, people. Multiplied. You need factors. You need things multiplied. All right, we need an x times an x for the front, a -5 to produce a -4. That's a -5 and a +1. There's the factoring of that quadratic. Therefore, now I can set each factor equal to 0 and solve the little equation. I get x equal -1 for that one. I get x equal 5 for that one. How many got -1 and 5? 1, 2, 3, 4, 5. Oh, I'm psychic. Or psycho, whichever way you want it to be. All right. You got to factor it. And a few of you may have stumbled on it because you played with it. I got news for you. SAT, ACT, you don't have time to play around with it. All right, take you forever. You'll never get anywhere. How do you solve it? By factoring. Factoring. Zero product property is by factoring. Okay, so to solve quadratics by factoring. How do you do it? Well, if it's not already set equal to 0, make sure you set it equal to 0. In other words, get 0 on one side, everything else on the other. Then you factor, and then, of course, set each factor equal to 0 and solve for the value of each factor that makes the factor a 0. Okay, so again, that's basically what we just did a moment ago. All right, so now that we just went through all of that, why don't you go ahead and do A? Quadratics by factoring if you can't factor? The answer is no, you cannot. Or polynomials as well. All right, this is already set equal to 0, so I don't have to worry about part 1. Number 2, factor it. All right, I'm looking at my middle. I need a positive 5. How about 7 and 2? How about if the 7 is positive on my outers for a plus 7x? Therefore, that leaves the negative 2x on my inners, and sure enough, that's a 5x in the middle. Therefore, x equals 2 and x equals negative 7, right? How many got that correct? All right, much better than 5. Awesome. Now we're rolling. All right. So x equal 2, x equals negative 7 as you factor that and set it equal to 0. All right. Try B. Try B. All right, I'm going to check you for a second. How many of you factored out the common factor? Good. And the rest of you forgot the key ingredient of every factoring situation. Factor out common factors first. All right? Factor out common factors first. Don't forget, it makes life a ton easier. So what? We're factoring a 3 out of this. Right? Now we're factoring the trinomial. I got to use 2n and n. What am I looking for? Again, don't neglect what I'm after a positive 5n in the middle. I have 3 and 1. That's all I have. But you know what? I got this 2. If I put the 3 here, that's a 6. And a 1 in the middle, a 6 and a 1 can get me a 5. What do the 5 need to be? Positive. So I need the 6 to be positive. Positive 6n minus 1n. There we go. That's the correct factorization because my outers and inners give me the middle. Now let's finish it off. Can a 3 be a 0? No, a 3 is a 3. A 2n minus 1 can be a 0. And again, add a positive 1 to both sides, divide by 2. So hopefully you got 1/2 as one possibility. And from the other, when you solve that little equation, you got n equals 3 as the other possibility, negative 3. So a half and negative 3. How many got that one correct? Okay. And again, save yourself the hassle. Make sure you look to factor out common factors first. Factor out common factors first. Oh, let's look at C. So what do you see when you see C? What thought comes to your mind? Good. Difference of 2 squares, right? That's the thought that should come to your mind. And therefore you say, it's already set equal to 0, piece of cake, 2 parentheses. Plus in the middle of 1, minus in the middle of the other. Square root of the first. Square root of the last. Right? Difference of 2 squares. Therefore, x can be a negative 3 or x can be a positive 3. By the way, if you so choose, you can write that as one thing by using the plus minus, right? Either way, same answer. X equals plus 3, x equals minus 3. Notice we're doing quadratics, and notice we're getting 2 solutions, because quadratics have 2 solutions. Real and or imaginary, depending on situation. Windows is added again. Go away. Okay, look at D. So somebody raise your hand, and what do you notice immediately on D? Leah? It doesn't equal 0. You have to, on D, right, David, get it equal to 0? So hopefully you're going to add a negative 11x to both sides. Normally I wouldn't show this in Algebra 2, but just to help some of you, right, we're going to add a, so now I have 4x squared minus 11x plus 6 equals 0. And now I'm ready to factor, right? Okay, for time's sake, just want to stay together on this one. And I want to refresh your memory. Because of this 4x squared, remember, we could be 4x and x, or we could be 2x, 2x, right? That 4x squared gives us two possibilities. You got to be aware of both. You hope the first one you start trying is the correct one. In this case, it is. So again, I'm after the middle. I'm after a negative 11x. I've got a 6 to work with. So 6 and 1, 2 and 3. You know what? If I put a 3 right here, that's a 12. I'm awful close to 11, aren't I? And again, if I use a 6, the other one's got to be a 1. Can I get to 11 with a 12 and a 1? I think I can. What are the 11s? They're negative. So I need negative, 3 and 1? Oh, 3 and 2. Now I'm at 12 and 2. I'm at 10. That's not even going to work. All right. Off with that. All right, but that's real life, right? Okay, let's go with the 2 here. 2 times 4 is 8. And 3, hey, that could be 11. And you know what? My last term has to be negative times a negative, doesn't it? So that's the only way I'm going to get to negative 11. So negative 2, negative 3. Sure enough, this is a negative 8x. And this is a negative 3x. And there's my negative 11x. That is the correct factorization. Then you just got to keep playing. But notice if you don't check the middle, you're going to make a mistake. And you got to be careful there. Okay, now we're ready to finish it off. 4x minus 3 equals 0. So you would add a positive 3 to both sides and divide by 4, right? X equals 3/4. And the second one is easy, x equals 2. So you get 3/4 and you get 2. So on that one, you set it equal to 0 first. And then you continued on. All right, 2 more examples. Okay, so same scenario on E, only there's a little bit of a difference here. Let me just pay attention here for a second. Most students don't factor if the lead term is negative. The lead term, the front term is negative. Most students don't factor as well if that's the case. You can do it that way, but again, most students factor better when the lead term is positive. This is the lead term, right? The cube term. So I'm better off moving the 2 things to the left so that I end up with y cubed minus 5y squared minus 6y equals 0. So I added a negative 5y squared to both sides. I added a negative 6y to both sides. Somebody tell me what would be my next step here as I go to factor this. What would be my next step? Josh? Yeah, get that common y out. There is a common y here. By the way, there's 1 or 2 of you in here where you magically factor without ever showing taking out the common factor, and then magically the correct factorization appears. You want me to tell you where that came from? The internet, a friend, or the answer in the back of the book? Just so you know, I know what's going on, all right? If you magically factor from this all the way down to here without this middle step, I know where it came from, and it wasn't your brain, okay? I'm just telling you, I know, right? And it's doing you no good to do it that way. No good. You got no benefit out of that problem. None, none, none. All right? And again, I'm talking to a couple of you in here. All right, so we got a y squared minus 5y minus 6. By the way, how many solutions are we expecting? How many? 3. This is a 3rd degree. I'm expecting 3 solutions. Let's see if this thing factors, I hope. Y and y, yeah, negative 6 and a positive 1. Again, I'm checking my outers and inners to get a negative 5y, and that gets me a negative 5y. So look, we got 0 for this y out front. We got negative 1 for that factor, and we got 6 for that factor. Again, y plus 1 equals 0, so y equals negative 1. Y minus 6 equals 0, so y equals 6. 3 solutions. Just what we expected for a third degree. And by the way, we're doing ones right now that give us real number answers, but the 3 solutions, some of them can be imaginary numbers. We'll get to that later. All right, for some reason, students miss F all the time. I know not why. It's like one of the easier problems. But students routinely miss this. So would you agree we're going to move the negative 5x to the other side? Okay. So you're going to end up with 2x squared minus 5x, right? Because you added a negative 5x to both sides equals 0. And again, I don't know why, but students always miss this. So what's next? What's next? What's next? Sarah, you've been quiet back there. What would you do next? Which is going to factor out the x. Again, those of you that still don't know how to factor, on HCS math class, go to the Algebra 1 videos from last year, chapter 10, and you better start watching the factoring videos, because you got to know how to factor. You just have to. All right, so that's where we're at. Look, we're ready to finish it, but I don't know why students miss this type of problem. It's so easy. X equals 0 for that one. Again, I already know this is a 5/2, and most of you already know it's a 5/2, but for those of you that don't, you set the parentheses equal to 0, you move the 5, you move the 2, and sure enough, you get 5/2. Okay, I think on your paper, I think this says 32. Is that right? Is it 33? I have it correct on yours? Okay, good, because that's supposed to be 33. Remember, the green is only for those who have a B or above in the first quarter. It's optional for everybody else. You don't have to do it if you're not in that category. B and above, you do have to do it. Stay up. Don't take a day off. Hold on. I want everybody to freeze. Freeze. Stop. Everybody stop. Still my time. I got 5 minutes left of class time. I want to do a couple things here real quick at the end. Okay. So first off, how do we start this whole thing? Freeze means freeze. It means stop fiddling, stop grabbing your papers, stop doing something else. It's my time, not yours. So how do we start? We start it with, you better be able to recognize something's quadratic. How do you recognize it? You've got a squared term. When that happens, then your brain should say there's 3 ways to solve this. I can factor it, setting it equal to 0. I could take the square root of both sides, or I can use the quadratic equation. That's how you have to start these. When you're solving by factoring, what's the key to the zero product property? Meaning, when things are multiplied together and the result, the product is 0, at least one of them has to be 0. It's that principle that we use to solve all of these. And we went through a progression, getting you to the point where you finally have to do the factoring yourself. And then we started factoring. Again, this is something you should have in your brain as well. If you're going to solve by factoring, make sure it's set equal to 0. Factor it. If you can't read the answers right off the factors, set each of the factors equal to 0 and solve. All right, last thing I want to mention to you here briefly is this. Okay, so I got a bunch of stuff on the bulletin board there about your brain. Okay, so most of you already understand this. A lot of you don't understand this concept. Fire it until you wire it. Your brain works on the concept of things that you learn make connections of your neurons in your brain. And the neurons in your brain make these connections. You have dendrites, which are the receivers. You have to fire your brain to be able to make that connection again. Here's the point. The more you review something, the more you fire those neurons, and the stronger that connection gets. You have to practice to wire it. There's still numbers of you in here that you don't practice. You get your answers from who knows where, the internet, a friend, a tutor does it for you, and you watch them, whatever, I don't know. But you have to fire it if you're going to wire it, which also means the more you fire it, the stronger you wire it. So some of you, you'll do your homework tonight and you'll put in a good effort. You are making those connections in your brain, and later on you have to make those same connections on your own on a quiz or test. Everybody would be wiser to keep reviewing the material and keep it fresh. Some of you that are struggling in here, you know what you need to do? Every day you need to read through your notes. It's not a big thing. It's not a big study time. It's a read through your notes for the current chapter. It'll take you probably a couple minutes if you tried to do that today. Just read your notes. What are you trying to do? Refire those connections and make them stronger. For some of you, those connections aren't strong. Some of you, the connections can be stronger. Some of you, you have a strong temporary connection. You don't have a strong permanent connection. Therefore, a year from now, when you take the SAT, you won't remember anymore. Oh, you remember okay now because you got good short-term memory, but you didn't fire it enough to permanently wire it. And if you don't care about your SAT in a year from now, then fine. But if you do, even if you're good, you need to regularly study and review to make it permanent. That's the key. That's the way the brain works. You can't get around it. All right, now it's your time.